Oh, so Ross was just saying he's in California. He's got some storms. I hope everybody else is okay with the weather.
And funny enough, I told you it was a sunny day, but the more I sit here, I'm now hearing rain pattering on the garage door. So that did not last too long.
Didn't last long. Yeah, but San Diego is pretty perfect weather, like almost all the time.
Yeah, I think we deserve this every once in a while.
Yeah. Okay, we're up to like 18. Welcome, welcome for the people that are just joining us. Okay, we'll get started. For those of you, so I'm Maureen. I am one of the partnerships. We'll talk about the college credit. Actually, you know what? Let me take a moment to answer that before we get going. So UCI has, worked with Polygence. We have a partnership with them where we are the only ones that offer, University of California Irvine college credits, and they have reviewed our programs. They've reviewed projects that students have done, and they will give 3 college credits through the University of California Irvine Gifted and Talented Institute. There are some parameters, like it has to be a research paper that they're giving the credits to. It can't be like a podcast or a website or something like that. So there are some parameters involved. The cost is $1,700. So do you know can they be counted towards the UC GPA calculation? That I'm not sure about. I put my email in the chat already. You can I will look into that and email me because it says anonymous attendee. Look at that and email me and I'll try to find out. But you do get a transcript as if you took a class at any university, and you can put it on your application. But also when you enroll in a college, you can turn over that transcript and get those 3 college credits as if you took a class on a college campus. Okay. So anyway, welcome everyone. I'm Maureen. I'm one of the partnership managers. We're thrilled that so many people want to come and learn about artificial intelligence. I would like to introduce Ross Greer, one of our amazing mentors. He's worked with quite a few kids here at Polygence, and I will let him take it away.
Yeah, hi everyone. My name is Ross, and I am a 4th, 5th-ish year PhD candidate at UC San Diego. And more importantly for tonight, I'm a mentor with Polygence. And I think I've passed 15 students I've mentored now on individual projects, and also mentored through the Pathfinders program to introduce them to what it's like to apply to college and think about what you might want to study and start to kind of hone in on the next chapter of their education. And I absolutely love mentoring with the Polygence program. Having mentored with a few programs, it's really unique in that you have a supportive staff from beginning to end, watching over the student as they're being mentored, and the mentors to provide support if they need any resources. So if you have any questions about the program itself, always happy to talk about that. A little bit about me. I thought it'd be more fun, instead of sitting in my office, to go out to my garage tonight. This is the lab garage. You can see behind me, I have a fully instrumented Tesla. We have a bunch of cameras, LiDAR, fun sensors inside and outside that car that I do my research using, and a crash test dummy waiting on the other side. And in a few slides, I can probably talk a little bit more about my research, but that's just the broad overview for now. Okay.
So we really want this to be like an Ask Me Anything situation. So as we're going through the process, if you have a question, put it in the Q&A, and we'll try to address it as we're going through to make sure that Ross has time to answer everybody's questions. Okay.
And if I give just a small trajectory, I went to high school east of Sacramento in California, fairly small high school, about 2,000 students. Our top math class was at AP Calculus BC, which I know for those of you in the Bay Area, that's probably like a sophomore math class. So definitely went in with kind of more of an average background and then became a very small fish in a large pond at UC Berkeley. There I focused more on studying physics and semiconductors. Went out and worked for a couple of years, realized I was not in love with semiconductors, but I missed middle school robotics. So I took a detour back to UC San Diego and did an MS and continued doing a PhD, where I now study AI, computer vision, and a lot of human-facing applications in safety and co-creativity. And yeah, I'd be happy to talk about any of these experiences if folks have questions. Otherwise, we can dive into talking more about introducing AI to high schoolers.
Oh, wait, we got a question. Has Ross mentored students who are interested in creating machine learning algorithms in diagnosing cancer and other disease through imaging data?
Yes, and so my specialty is in image processing within the field of AI. So I love any project that involves image data. I get very excited about. The challenge with diagnosing and collecting medical data is often having that data accessible to students. There are a few public data sets released. I highly encourage any interested student. I don't think I can type this in the chat, but if you go to kaggle.com, that's KAGGLE.com, there's a great collection of data sets and also tutorials and competitions for students who want to get their hands dirty with AI and learn some of the beginning foundations. There's a few cancer diagnosis via imagery data sets and also neurological conditions that you can look at brain scans. But other than that, it's going to be hard to get your hands on hospital clinical data so you can do this type of analysis. That said, there's a lot you can do with those existing data sets, and especially for a first-time project for a student, it's a great place to start and really fun projects to mentor on and talk about.
We have another question already. Can you help a student interested in research, including AI, to collect data? Example, measuring sleep and other factors influencing it.
Oh, absolutely. Yeah. A lot of my students, they come with these really big dreams about what they want to study. And then I have to remind them, we have to collect whatever data. If you're doing a data-driven process like most machine learning, you need to get that data set. So a lot of this time we're talking about, okay, what do you have at home? Do you have a cell phone? Do you have a better camera? Do you have a car with a dash cam? And we think about ways we can collect that data. Even sometimes with wearables, right? We can record some active hours if you want to do a sleep-related study. So yes, if a student's interested in a project, we usually try to find a happy medium between not needing to order expensive equipment, but still being able to collect data with whatever they already have at home or can order for, just a few dollars off Amazon or Target. But yeah, most of the time we can find some way to either get a hold of the data, create the data.
Okay, wait, would the knowledge in creating machine learning algorithms and some other data set, say finance, be applicable to other fields not related to the data set, maybe medicine?
Absolutely, yes. The most important thing, I think, when we are doing these mentorship projects, ideally we're leaving the student with not a specific application they have solved only, but also the understanding of how they approach that problem. And hopefully they're taking home a few different machine learning algorithms, image processing techniques, natural language tokenization techniques, but different things that have broad application, and then they can apply it to a problem of their choosing. But really that's the great reason to work with a mentor, is that instead of following a tutorial online, if you just follow a tutorial, yeah, you get the code for your application, but understanding what you're actually doing, some of the math behind it, and how those ideas might translate into other uses, that's what you get through the mentorship.
Okay, so let's learn what's so exciting about artificial intelligence. Let's learn about artificial intelligence.
Yeah, so I am too excited about this field, so I'm going to try to talk only 3 minutes about this. But AI is kind of this broad field that contains any set of algorithms that can think or act or behave the way that we like to think we're intelligent, or other animals, anything that has some type of cognitive process going on. We're trying to now replicate that in the computer and get the computer problem the same way we might, or even better. Most of the time when we hear AI, we're thinking about machine learning, which is a subfield of AI that has to do with collecting large amounts of data, learning patterns in that data, building a mathematical representation of the patterns in that data, and then applying it to a later problem. So I like to distinguish when we're talking about AI, it doesn't necessarily mean giant data sets, machine learning. It can also mean thinking about programming a system to respond intelligently to a prompt the way that a person might. So broadly, this covers topics in computer science, but sometimes my students, we don't even program. We were doing math the whole time together on paper. Other times we're just talking conceptually about how images work and how to pull a pattern from an image without doing any AI or machine learning programming. We're just looking at images and discussing these foundations towards algorithms that think like people do. In terms of career paths, I'm a little bit biased towards the research careers because of how much time I've now spent in grad school. But of course, all the software engineering companies that we see all over and popping up every day, these certainly have people who have studied AI that are helping to manage and make decisions using the data they collect. And in addition to the AI side of being the research scientist, there's also a whole support crew that's helping these projects become possible. These are the fields like ML ops. These are people who help to handle giant batches of data and temper them and get them in an engineered state so that the scientists can then use them for whatever inference they're trying to make. So I would say broadly, AI studies lead to software engineering, research scientist, data scientist type job titles. But who knows, could also be CTO of a startup, plenty of other roles out there.
Okay, we have a question. What's the barrier for someone who has completed AP Computer Science A and basic Python knowledge to create a machine learning algorithm? What's the average weeks/days required to create these types of algorithms?
Yeah, so the answer is that the barrier is actually lower than most people think. If you have basic Python knowledge, a good mentor can guide you through writing that program to do your first classifier. For those of you who have done any computer science, you know that phrase, hello world. It's the first thing that you teach the computer to type back at you, and then you're officially a computer programmer from that day. In the world of AI, we have a similar exercise where we write a program to classify handwritten digits. The Postal Service collected a bunch of examples of people writing zip codes and decades ago and said, can we do this? Can we automatically teach a computer to read the zip code off an envelope? So solving that problem, that's kind of the hello world of AI. And you can do that in a day with a mentor. They can walk you through. The difference, though, the challenge here is that while you can do that in a day, to understand how those lines of code you wrote are working, think about how they might fit to a different problem space, debug when there's an issue that comes up in typing that. This is where the mentorship process, depending on what the student would like to learn, you can spend a month talking about that problem. You can spend a day and then move on to something else. So it really depends on the student's interests and how much they value understanding and learning some principles versus getting out a quick application for a science fair that they really want to try to apply something for. So there's a lot of wiggle room here. But my main point I want to drive is that if someone has even some basic Python, not even having taken AP Computer Science A, usually that's enough for a mentor to get them started and actually create a functional AI algorithm in just a few sessions.
Okay, here's another question. Does a student have to take Calculus AB or BC first before they can do an AI research project with you, which means they have to be in at least 11th grade in order to do this type of AI research?
I would say no. What I would, though, expect of a student is that they're willing to think about problems mathematically. That doesn't mean that they need to take calculus, but that might mean that if we're talking about, I'm going to throw out the word gradient descent here, which is the way that the AI algorithm learns to improve itself. I might ask them to think about standing at the top of a mountain and how they would walk down that mountain and thinking about all the directions they could walk, what it means for a direction to be steepest. So we might need to think about the word slope for a minute from our algebra class. I'm not going to make them say, oh, that's the first derivative of a multivariate function. But if we can at least think and talk together about how they're learning and start to get some of these larger analogies in our head and think like a mathematician, that's totally sufficient to work together.
Okay, we got another one. When working through Polygence to do a science or bio research study, how do we tap into an AI PhD mentor and bio specialist? Are there mentors that can mentor both?
This is a really good question for me because I ran into a fun situation with one of my students, which was not actually my student to begin with. One of my students is a incredibly talented archaeologist out of high school, which I did not know was a possibility, but I guess through some connection, he ended up at visiting some historical sites in Rome on a family trip, found some really interesting pottery, wanted to study the glyphs he saw on it in more depth. And so he ended up linked to a archaeology specialist mentor. And then he told that mentor early on in their sessions that what he wanted to do was use generative adversarial networks, which is a cutting edge AI technology, to try to reconstruct the glyphs from their partial fragments. And this archaeology specialist went, cool. And then ended up through the grapevine of the great Polygence support team connecting to me. So we ended up co-mentoring the student for a while, until the point of departure when the student realized, okay, I really want to do a computer science project with a flavor of archaeology. And then we started working together and I kind of took the mentorship role. So the answer is you can tap into both. It's possible, it's been done before. The advice I would give though is be very clear when you're applying for the program, what, to the best of your knowledge, it is, what's the true nature of the problem. If it is an AI problem, within the domain of biology, you probably still want to be with an AI specialist because they can help you program and get your solution. And behind the scenes, the mentors, we have our own giant chat. So all the time I'm writing to that chat, I'm saying, hey, I'm doing an AI project related to social media, psychology, and mental health for teenagers. Can one of you psychologists out there tell me, are we approaching this particular scientific fact the right way with the work we're doing? And we have a great network in that sense. So I would say work with your mentor matchmaker to make sure that you're with the right person for the project you want to do.
Yeah, that would be your admissions person. So when you're on a call for admissions, again, and when you fill out your application, be very clear what you want to study so that they know, who to match you with. Before we have another question, but before I go to that, I just want to say how much I'm loving these questions. We want to inspire you students. And so you asking these questions is the best way to, one, hopefully inspire you, but also for you to know if this is the right thing for you. So, keep the questions coming. We love it. Okay, so here's another question. Does this program target students who are newer to AI concepts? If you're more familiar with deep learning concepts and libraries such as Keras PyTorch, is there an opportunity to explore more advanced topics and projects?
So the cool thing is, unless you are somehow coming in at a more advanced level than whatever mentor you're paired with, I doubt that's going to happen because we've been in this field for a little bit of time now. We can take you wherever you want to be. So if you are brand new to AI, I love getting new to AI students and I teach them all the fundamentals. I also get students who have done a course online, and honestly, more often than not, these students, they rush through the course, they've done a boot camp, which I don't always recommend because they don't actually have a grasp of the fundamentals to do the advanced stuff. So some of our first 2 weeks might be correcting some of the missed gaps in the knowledge from that past boot camp. But then, yes, we absolutely move on to more advanced concepts. We can talk about more state-of-the-art techniques, things that build off. If a student has learned deep learning through convolutional neural networks, that is just the beginning. From there, we talk about advanced architectures. We can bring in transformers for some of my students, GANs. We can really dive deep from that point. It's just a starting point.
Okay, here's another one. What is your favorite project that you have worked with a student on?
Ooh, that is a tough question. There have been so many fun ones. I think one that I really liked, I had a really motivated student who was so tired every day that his parents would go to drop him off at school. They would have to make this left turn at this red light. And always people who are running late would cut in right in front of them. And he said, this seems dangerous. And he wanted to fix it. So he actually took a dash cam in his car, his parents' car with his parents driving, and drove that intersection every morning to collect some data on it. And then together, we coded a whole ensemble of neural networks to detect all the traffic lights, the traffic light states, the lanes, what lanes the cars were in, how those lanes were married to the lights, to try to identify anomalous behavior in those drivers. And the funniest part for me was on one of these days, he comes with a video. He says, look at this. And I'm watching like, oh my gosh, that is the worst driving I've ever seen. This person was cut right in front of you. I'm surprised you didn't get in an accident. How'd you know to slow down? And he goes, oh, that was my mom driving in front of us. And it was the most fun session we had, but we got to show how all of these networks he had built identified his mom's car as being possibly unsafe to the driving scene.
That is funny. Okay, are there common projects that you've done? Like, what are there common themes that you see with students and for the projects that they want to do?
Yeah, there's one that I actually see a lot that I try to immediately steer students away from, which gives me a chance to kind of bring up some more topics in AI and in general, just ethical science. There's this common, I'll say, boot camp project called facial emotion recognition, where you're given a small data set of people's faces and you're supposed to guess what emotion they're experiencing. And all of us in this call probably know that sometimes I could be happy or stressed, but my face might show the exact same smile expression. And the image doesn't necessarily say how someone's feeling. So I always have to stop these students kind of at the beginning and say, you know, we can build a classifier that looks at images and classifies, but let's think like scientists here. Even if that classifier is working well in the way that we've labeled the data, is that actually an accurate portrayal of how someone might be feeling? And we get to go into some other, I then share some psychology research and some later developments, because that emotional recognition data set came out in, I think, 2008, if I'm thinking of the right one. And we are now well past that time. So a lot of times, though, I like doing projects that involve people, because that's the lab I do. We're doing all these studies on human drivers. So it's fun for me to get to kind of say, in addition to the base thing you think you're solving, what's the actual question? Another example of this with another student I had, he wanted to analyze when people might be falling asleep behind the wheel. And so he tried to make something that could tell if your eyes were closed or open while you're driving. Now, we blink while we drive, we wink, we close our eyes and stretch our eyes for a second. So we had to talk about all these other topics like signal post-processing and thresholding to figure out how long an eye could be closed before it's an issue. And yeah, so I would say, to answer the question, general themes of data involving people is great because we can collect that easily from just ourselves or our family members, and we can really get interesting insights and learn about scientific principles underlying neuroscience. So it's not just a fake guess at an image.
Okay, great. Here's another question. Ross, when talking about the bioresearch with AI, you said students should be clear about the problem with the AI when filling out their Polygence requests with mentors. What if the student is not knowledgeable in AI and they'd like to learn how AI can be used in their area of research? Who can help point them to things to read and ideas to incorporate?
I would highly recommend that they pair with an AI mentor in that case, because the AI mentor, ideally, you can come with, you say, this is the data I have. What from this broad field of AI could I throw at this data to start to learn something from it or to build off of it? If you talk to a biology mentor, you're going to get a different answer because they might not have the computer science techniques. They might be able to tell you about what's going on in the data, but the AI scientist is going to be able to look at the type of data you have and give you a whole list of techniques you could use to process that and draw analogies to other fields. I hope that answers the question. Feel free to elaborate if I missed the mark on that one.
Okay. Okay, so let's move to this. Here we go. Ross?
All right, what sparked my interest in AI? For me, it took finishing my undergrad and realizing I was unhappy clinking my glasses against the microscope I was looking into in the labs I was interviewing with for growing crystals. And I went, probably not as fun. And then I tried to do some soul searching and remember when I was really happy. And I went all the way back to my middle school robotics club in my head. And then I got a little bit of work at a startup that was making robots that make breakfast sandwiches and coffee. And I'm like, okay, this is fun. I enjoy this. I have no idea what I'm doing, but I enjoy this. And that brought me back to UC San Diego. And it only took a couple of classes for me to click and go, oh, This is the type of work I really like doing. I could do this all day and not sleep and be really happy still, which probably brought me to the PhD, where I'm not sleeping but doing that work all the time. It's a fun field. Yeah, no regrets having immersed myself in it now. In terms of classes in high school and college, I mentioned at the beginning, I took the best classes I could at my high school, which for me was finishing with AP Calculus BC, 1 year of physics, 1 year of every science subject, biology, chemistry, 1 year of computer science, because that's all we had. Then at college, I took the whole engineering physics curriculum, which was a lot more on the side of semiconductor physics than it was computer science. But I got to do the computer science core curriculum at the same time, including discrete math, linear algebra, multivariable calculus, probability, statistics, all of those courses, the math courses in particular. Getting that breadth from undergrad was really important for me to do well in the later grad programs. So yeah, I hope that answers. During undergrad, just take an introductory breadth and do your best you can in all these fundamental courses. The specializing, that happens in your senior year or beyond in grad school. So what do I plan to do after obtaining my PhD? I would love to teach as a faculty member and keep doing research. That's my career path, career goal. And my experience at Berkeley and UCSD, wildly different experiences. If you want to talk about cutthroat campus and non-collaborative peers most of the time, that's Berkeley for you. It's you do your best and you feel like a superhero when you leave an exam because you have studied your butt off all by yourself and you did it. UCSD, totally different. You have professors who are supportive, giving, oh yeah, take some extra time on this if you need it. Here's a study group I recommend for you. People chatting, having a great time in the library, learning together. It's just a different vibe. So they're both great in different ways. And I would say when you're a student touring the campuses to figure out where you might want to go, if you're choosing between two places, figure out how students are interacting with one another. Talk to some professors, see if they're nice and excited and engaging with you, or if they're austere and very much experts in their field, but maybe don't have the time to share with an undergrad. And decide what you want out of that, because Berkeley comes with this prestigious name attached to it because of that separation, that respect, that authority there. So if that's the vibe you want for your college experience, I loved going to Berkeley. I also love being at UCSD right now. So just figure out where you feel comfortable.
Okay, we got a question. Hey, Ross, I'm a freshman in robotics. How did your journey from robotics bridge to AI? What is the pathway you took to get there?
Great. So I love hearing this as a student in robotics. So you have probably at some point, I'm just going to guess, done like a first Lego robotics competition or something along those lines. And you're given a limited number of sensors for this, right? So maybe you build your first robot just with those motors and you try to get it to go in a straight line and you notice it starts to turn a little bit left every time you drive it. And you can try to maybe make some small adjustments to the motor power, but you can't really control it. And then at some point you put one of those infrared sensors or a bump sensor on the front that starts to get a measurement of where it is relative to a line. It can start to wiggle its way forward, right? So now take this problem of getting something to drive in a straight line and put it on the real world in a road. You can't really read the lane lines by driving over them. You have to actually start to infer in front of you and take a picture the same way that our eyes take a picture of the world. Guess where the lane lines are. Guess where we are sitting between those lanes. All these problems, these are AI problems, because the way they're solved today is we take in a ton of data. We take in a million pictures of the world and learn where those lanes are. And we learn how to find the relationship between our best guess, our best statistical probabilistic guess of where those lines might be and where we're sitting, and combine all of those together in intelligent ways. So it's a broad jump from middle school robotics up until, going to work at one of these companies that are doing intelligent vehicles problems. But it's all connected. Basically, you'll hit a limiting point with your first Lego robotics without those sensors. And then you'll add a sensor to your vehicle and you'll go, oh, shoot, how do I actually use this sensor in a way that makes a better robot? And that's where AI gets to come in.
Okay, here's another question. Do you have students who have built reinforcement learning projects, in particular in-game agents?
Yes, and there are some really fun Python libraries that will let you start to do this on your own. There's in fact one that lets you emulate a Super Mario game. And so you can build an RL agent to interact with the Mario World 1.1 environment. But there's plenty of other interesting RL frameworks. Out of one of Berkeley's labs by Sergey Levine, there's a set of benchmarks they've released with basically you've seen those humanoid wooden panels that you can like help to point to body parts on or show outfits on. They have a rendered model of that you try to get to run without falling over. And so you're teaching this RL agent how to walk like a human. And I've done projects in these environments. I've mentored some students in them. So if that's something you're interested in, I'll just tell you RL can be an advanced topic. I would usually recommend a beginning AI student start in a supervised learning or unsupervised learning area first and then do RL. RL, in terms of actual state-of-the-art work, it's starting to get popular in the research world. But if you want to end up as a software engineer out of undergrad, more often than not, the answer I'm getting is that if you want it to work, don't use RL, which is, to me, in probably 10 years, the RL approaches are going to be great, but maybe not yet. So I'd recommend not explore that if you're curious and interested, but if it's your very first AI project, start with a supervised learning task. That'll get a lot more commonly seen fundamentals. It'll better prepare you for maybe your first college course in it.
Okay, what physics class did you take in high school? Was it algebra or calculus based?
It was the calculus based course. I did AP Physics C. Okay. And yeah.
Okay, you mentioned middle school robotics. Do you remember what program you did in middle school?
Yeah, that was a long time ago for me, probably compared to any high schoolers that are asking, but I was in the first Lego robotics course. So this was actually back when they were little yellow bricks instead of the cool like silver orangey robots they have today. Just basic systems with a couple motors and wheels spinning, and that was about it.
Okay, what does RL stand for again?
RL is reinforcement learning. It's a different type of machine learning process where instead of having a bunch of labeled data, you have an agent in the environment. Your agent can take certain actions, and as a result of taking those actions, it can receive some reward from its environment. So it basically learns by doing. It's kind of repeatedly sampling and trying things in the environment, and it learns by exploring, which is different than learning based on all the data you've seen.
You talked about Kaggle as a source of data set. I'm interested in the field of military aviation technology, defense, or other weaponry. Are there publicly available data in that area that I may be able to do some kind of AI algorithm study?
Yeah, so this is a little bit hard to answer because a lot of true military data is, for good reason, kept secure. I would point back to my credentials page for a second. So one of the internships I did was at MIT Lincoln Laboratory, which is a Department of Defense funded lab. And they have some awesome internships for undergrads and grad students. So I would encourage you, if you're interested in military aviation technology, they are completely Air Force funded, now actually Air Force Space Force. But they have great internships, and you can actually see a lot of really cool projects there. The advice I would give for someone who's interested in this type of thing, but may not have access to data now, is to look at projects that have satellite imagery data or projects that have radar data. There are quite a few data sets on Kaggle that involve observing the Earth from satellites and getting different types of imagery from that. There are also projects that involve surveying open water to, say, detect all the ships that might be there. And while this may not be offensive or defensive weaponry, it's certainly a way to use AI to study for the sake of security-based surveillance.
Okay, if a ninth grader has never learned to code, but wants to eventually do AI, what language would you recommend they start to learn first? C++ or Python, online or class learning? Is AI synonymous to CS software engineer?
So that's a lot of questions. I want to make sure I have that one open so I can get all of them. I would say Python. And my reason for Python is that it is the closest language so far to being written the way that we speak and the way that we think. If I give you the same code written in C++ and Python, the Python one, you could actually probably read the instructions and maybe write what I said on paper and be able to act out that algorithm. If I give you the C++ version, you're probably going to need to do an extra layer of decoding and thinking to understand what I actually wrote. So I always recommend Python. Plus, it's right now the most popular language for all these AI developments. Eventually, that Python code is usually translated to C++ so it can run faster on, say, cars that are processing in real time, but Python all the way for me. Versus online or class learning, I would say the venue is a little bit less important than the curriculum you're going to be taught. And I want to stress here, I don't recommend going into a boot camp that says master Python in 1 month. I have not mastered Python. I've been doing it for 90 months now. I'm learning Python every day. And eventually you realize really you need a very small core set of skills, very small. And then the maturity to go read online documentation to figure out what library you can use to help you in your function. So when a boot camp says you'll master Python in a week, and then they just give you a certificate and a program that's pre-written for you, you didn't learn anything in that. So I really stress, whether it's online or in person, get with someone who's going to actually teach you the material and just the basics. You don't need a ton, just the basics. Is AI synonymous to CS software engineer? No. There's a ton of computer programming that is not AI. AI specifically is referring to algorithms that try to replicate intelligent processes. General software engineering has a lot of different components. You have front-end engineers who build the beautiful websites and applications we use and look at. Back-end engineers who make those applications and websites work on the back end to actually process and handle the data. You have DevOps, where people are actually building tools to support the engineers that are building these things and keeping the information flowing through the internet. AI engineers who are drawing insights from that data. There's a whole web of different roles. So I'm talking about AI mostly, and I mentor projects in AI.
Okay, here's a question. Would you want to mentor a robotics team over Zoom?
Of course. I love mentoring. I'll speak about Polygence again for another second. There's a reason I have had 15 students. I love doing these projects. I want to be a professor, which means a lot of my job is going to be mentoring undergrads, master's students, and eventually PhD students to complete their own projects. And it's so much fun for me. So yes, I love mentorship in general. And regarding the Zoom component, so far I've had no issues mentoring anyone over Zoom. I used to teach in person also. Obviously, with the pandemic hitting, a lot of these programs have shifted to Zoom. And it turns out computer science really easy to work with over Zoom because you can look at the same code on the same screen. You can share steps. You can watch things happen in real time. So yeah, mentorship over Zoom for robotics, definitely something I like to do.
Is Java used in AI? How does it compare to Python?
Yes and no. Python is the language of AI research right now. And the reason for this is that it is so easy to read, to distribute, to get running on. It's just because the community of AI researchers have adopted it and chosen to put all of our time into using that language, that's kind of the language of choice. Now, I'm going to guess you're asking this because you took APCS in high school and you used Java in that course. So the good news for you, if this is you asking, Python is easier than Java because it's written the way we talk, the way we think. And I guarantee you everything you learned in Java in that APCS course, building classes, for loops, if-else statements, immediately translates to Python. You'll have no problems. It's even easier to run Python programs.
Okay, I just want to jump to the mentorship aspect, since that's such an important part of doing these projects and Polygence. So do you want to talk a little bit about mentoring?
Yeah, I'd love to. Mentoring for me is really about talking to the student and making sure that what we're doing is working towards their goals. The nice thing about being a few years older is that I actually know how I got to where I can look back on my path and see what were the important things that led me to where I am. So part of it is stress management for the student, right? If the student's really worked up about, oh gosh, I need to get 9 research papers done this summer so I have a chance at college admissions, I try to calm those worrying thoughts and then also guide them, okay, what are you actually interested in? And how can we make you stand out in that field by working on a project together related to what you care about? Sometimes this is identifying gaps in their knowledge. Sometimes I get really enthusiastic, excited students who did a AI boot camp and they have this functional notebook and they have no idea how it works. So we spend time going over it together and teaching them actually the AI fundamentals and getting them re-excited about the topic and starting at the level that they are at. The main message I like to drive home for my students is that we all come to our courses in college with different levels of experience. The person next to you might have seen this topic 5 times because they went to the most accelerated high school in your state. The person to your other side may have never seen this. It could be their first time. And everyone, especially in Polygence and especially in college, should be welcomed to learn and start wherever they're at. And a good mentor is going to bring you up to speed from that level. They're not going to expect that you have perfect coding already. They're not going to expect that this is your very first time. They're going to listen to you and help build your skills from where they are.
Okay. Oh, I didn't mean to switch. Boom, back. Okay, so somebody is asking for your email. They have questions that they want to ask about the topic of the traffic.
I'm more than happy to drop that in here for anyone who has follow-up questions at the end. You're more than welcome to reach out there.
Oh. Okay, and then somebody's asking how long the program is. So the Polygence, our main full program is 10 sessions. That you work with a mentor, you choose your topic, you learn about the topic, but also during those 10 sessions, you plan a project, and the student gets to choose what the project is. Is it a final research paper? Is it building an app? Is it building a website? Is it doing a podcast? For humanities students, we have students like sewing fashion gowns from like the 1700s. It's like there's many different things that our students can do. So they do that within the 10 sessions as well. If you'd like, you could add on 3 additional sessions to focus on showcasing. So you have completed your project and you have created this final project. How do you showcase it? What's the best way to showcase it? Is it putting it in a science fair? Is it publishing it in a journal? If it's publishing in a journal based on the topic that you studied, what's the best journal that fits with your topic? And those final 3 sessions, you will have a mentor who will help you walk through planning the next steps. And they will help you do the paperwork or whatever it is. They will make sure that you get to the next steps. Yeah. So there's a question about whether Ross would be willing to mentor in a program. There's a lot of factors that go into whether Ross is available. Ross loves, as he's already said, he loves working with students. So when you speak to an admissions person, you can say, I love Ross, but everybody loves Ross. There's availability that goes into play. So, we can definitely take that into account, but nothing is, we can't make any promises in this webinar tonight. So, but again, I understand where you're coming from. Everybody loves Ross. Somebody else is asking about the Python, and I had put it in the chat. They said chat's disabled. If you look at this, what's next, the bottom 3 bullet points here are resources that Ross had suggested. So the Learn Python is the resource that he had suggested. I put them in the chat before the webinar, thinking it'd be easy for people to copy and paste them in order to take them with them. So I apologize that the chat is disabled.
Yeah, can I talk about those for 2 seconds?
Sure, absolutely.
So that learnpython.org, this is what I pass on to nearly all my students if they don't already come in with a solid understanding of Python. And what I love about it is quick and easy and painless, and it is free. It is not a 1 week promising you the whole world boot camp. It has like a list of 5 different subfields. And I just tell my student, just do that, learn the basic subfield. It's like 8 lessons, super easy, free. You can learn a lot. We can talk about it. And once you have those down, I can guide you through any project. As long as you have the basics, we have a common language now to share, and we can start discussing and working together. And then these other two are really their blogs. One of them is by one guy who just loves computer vision and AI problems. And then the other one, Towards Data Science, is an offshoot of Medium, which is a popular blogging website. And people share their projects there. They say, here's the problem I set out to solve. Here's how I solved it. Here's my code. And they're fun to read. And they have such a wide range of interests. You can find people who used AI to generate musical compositions, to create visual dance choreography. It's really, someone like generated all the Pokemon soundtracks the other day and wrote an article about it. So if you're curious and want to learn more, it's a fun blog.
Mm-hmm. Okay, do you want to see what those first couple questions are?
Yeah, what advice would you give a student looking to further explore AI? I would recommend in your day-to-day school life that you're either probably in high school at this point or starting to steer towards college, keep taking those math classes as best you can and do your best in them. Being able to think about problems mathematically, statistically, probabilistically gives a really nice intuition. And learning how to do AI problems is a lot about just learning how to think about things that we usually encounter in the world as data instead of things. Starting to think about what we see as a collection of pixel values instead of just the picture that we're seeing. So the more you can kind of expand your thinking through a math class, the more I recommend going down that path. And of course, take your AP computer science course and take your introductory computer science courses in college. And I'll say one more time, the time when you really start to specialize in things, that's kind of your senior year of college, maybe late junior year, and maybe even grad school for some. So keep your nice wide net during undergrad, build up all those foundations, and then that way when you finally get to the point where you can build off those to explore, you have a really strong foundation to stand on. How might a research project help a student toward a career path in AI? A research project at this level, more than anything, is actually going to open up a lot of questions for you. So when you do your project on detecting drowsy drivers who may be sleeping behind the wheel, it's going to open up questions. You're going to build your first neural network. It's going to get 80% performance. You're going to go, geez, how can I get better than that? Why is it not better? And then suddenly your mentor is going to dump 9 research papers on you and say, look, these came out in 2023, and this is why it's not better yet. Here are all these open questions in the field. And hopefully you'll get really motivated to continue exploring those questions, and you'll start narrowing your focus onto one of those open questions and eventually explore that in grad school. So the research projects are really good at that. You learn the basics, you learn a approach towards a problem, just a singular approach, and then you identify, ooh, what's left to be fixed to make this even more effective. And this is why there are whole labs devoted to it. You'll start to pick that up while you work on the problem. What resources? I put some there. But also just talk to someone. I'm sure if you're involved in Polygence, you know about the Pathfinders program and mentorship. You're going to have your hands on a great mentor at some point. Ask them all your questions. If they're like me, they are going to really love talking about their research and can talk your ear off. So don't be shy if you have more questions.
Okay, we got some more questions. Does the showcase package will help or guide students to know where and how to publish the research paper? Absolutely. That's the whole, that's what we're here for. We want to help you showcase, and that is the purpose of that extra package. So yes. Can the mentoring 10-week research start at any time? Absolutely. Again, this our program is so flexible. First of all, we want it to be student driven. We want the students to choose the topics. We want the students to choose what their final project is going to be, but also we can be flexible and work around your schedule. So whether students are, whether they want to do it in the summer, whether they want to do it this school year, but they have, we know a lot of students have a lot of commitments. We can work around the commitments to make sure that you are able to do the project and really find it fulfilling. Ross, I think this one's for you. Are there any books you'd recommend?
Ooh, that depends so much on what you like the most of this broad field of AI and what level you're at in your programming. So I hesitate to give any recommendations right now blindly, but once you connect with a mentor, or if there's a little more information you want to add in a follow-up question, maybe that would be a better way to get a recommendation, because a lot of those heavy textbooks, I don't want to assign you 700 pages of reading that's not relevant to you.
Mhm. Okay, here's another question. Would you recommend taking a statistics class in high school?
Yeah. The sooner you can start learning about probability, statistics, and start to think about ensembles of collected information and how you can get information about that whole group as a whole or individual members of that group in relationship to the whole. That way of mathematical thinking goes a long way, not only for AI, but for biology, for chemistry, for physics. There's statistics everywhere in statistical techniques. So yes, definitely. And also when you take that course, in any of your math courses, try to start transforming instead of thinking it as like a chore or requirement. Just ask yourself, okay, what about this course am I enjoying? And ask your teacher, where does this fit in later down the line? Because statistics, I remember from high school, a lot of people were taking it just because they felt like they had to. It's a really cool course and it has so many applications.
Yeah, even just general business, people in business use statistics all the time. Okay, I'm in ninth grade. I have the passion to do a research project. Can you show me project ideas using AI if I sign up? Um, yes,
Someone can.
yeah, someone can. Also, if you go on our website, we have it's over 2,000 project ideas. I think it's it's closer to 3,000 than 2,000. First of all, you can look. You can go and look at completed projects and they're broken down by subject matter. So you can click on the subject matter and look at projects that students have already done. But then there's another place on our website that I can't just do the breadcrumbs to teach it, show you how to do it off the top of my head. But if you look around the website, there is another place that, again, by subject matter, you can click on it and get project ideas. So that definitely, and again, once you're matched with a mentor, they will definitely talk to you about project ideas.
And I also want to challenge this attendee. You have the passion to do a research project. I want you to explore that one step further. What question are you passionate about? Pick a specific topic or idea. And if you can bring that to your mentor, that's where they can really start to shape your idea and go, oh, you brought up, you want to make a self-driving car. Okay, let's pick a sub problem within that related to that you're excited about. And it'll really help steer that matchmaking process and also get you to a project that you care about. It's much more fun for the mentor if it's something the student's also really excited about.
Yeah. For those who are interested in publishing research paper involving creating AI algorithms, will 10 weeks be enough?
It depends on so many factors, and it also where you want to publish. We have high school journals, we have conferences, workshops, blog posts. I wrote a blog post on the Polygence website that I would like this person, anyone else with this question, to go check out, all about how you can showcase and do computer science research through Polygence. And I walk you through all the different ways you might publish in 10 weeks. Hopefully that will answer some of your questions. Sometimes it's enough. Sometimes you need a little bit more time. Sometimes I had one student within 3 sessions, they had their work published. They wrote a giant survey paper on semantic segmentation in autonomous vehicles, got picked up like that. That student, amazing. And that could be you, or you could be a 10-week. It really depends.
Okay. Somebody wrote, I wanted AI ideas, not just any other subjects. I think this is the person was asking, it must be the person asking for project ideas. Again, you could go on the website, you could search computer science, AI, you're going to find project ideas. They are there. Following up on the question, are there any books you'd recommend? Personally, I'm familiar with the basics of AI, but would prefer to avoid textbooks, obviously. I'm particularly interested in learning about AI methods and techniques since there are so many, but I know of so few. Some things I'm familiar with are CNNs and transformers.
Interesting. Okay, and to this person, I might ask if you're interested, since you mentioned CNNs and transformers, if you're leaning towards image processing as something you care about and understanding image data, I might actually point you to a book by Gonzalez and Woods called Introduction to Digital Image Processing. And it's not completely AI-centric, but it teaches you a lot about how images are processed and how those convolutional layers work. So I usually point people interested in the image domain over there as a first place so they could get some new ideas from. There's a lot of AI offshoots from that book, even though it's not really an AI book. I'll think of some other ones over the next few minutes here.
Ross, have you mentored the student to do a financial trading AI program?
Yes, but you are not going to build the next award-winning mutual fund probably over 10 sessions. If you want to know a funny fact about the AI industry, I was at ICML last year, the International Conference on Machine Learning, and they have vendors that sit out front and try to entice all these researchers to come talk to them at their booth and get recruited for their companies. About 90% of the booths are high-frequency trading companies that are trying to grab the top cutting-edge ML scientists to come and do proprietary work you cannot publish once you work there, which means a lot of the research in financial trading is not open source. It's not available for us to build off of. And it also means there's a pretty high barrier to entry. If these people are recruiting at like a top tier conference to try to grab talent, we can build bots together that there's Python libraries that can make trades for you via APIs with Schwab, with Robinhood, but it's it will be a fun experiment, but I would not put more than $100 towards this at a high school level.
Okay. Somebody asked if we could share a blog. Did you mean the Polygence blog?
The Polygence blog. Mm-hmm.
Yeah. So yeah, you can just go on Polygence. We have a blog, and then within the blog, there are certain subsections that you could look at.
I have been told by someone on the Polygence team that if you type how to do computer science research into Google, this will be on the first page. So if you find the Polygence link there, yeah, you can also get to it that way.
Excellent. Is AI a subcategory of machine learning?
Other way around. Machine learning is a subcategory of AI. AI is what we call anything that is making intelligent decisions, that's thinking maybe like a human or another intelligent thing might think. Machine learning is the part of that that tends to use large amounts of data to learn about those patterns and then make decisions.
Okay, we have a couple minutes here for a few last questions, but I just wanted to give you information about, my email is maureen@polygence.org. If anybody wants to email me, ask me any specific questions, but also like if you wanted to sign up, what are the steps to do so? You can go onto my account on the Polygence website, start an application, and our team will reach out to you from there. And then somebody also asked about, are we going to be doing any medical research? Our next mentor journey webinar is next week, and it's on cancer research. So here's the information for that. Does anybody have, and oh, we got another question. My son recently conducted an AI project. Oh, here we go.
Oh, great to see you. Yes.
Yeah. He's a great mentor. How much guidance and help can my child get to complete publishing the research project? Do you want to take that, Ross, or you want me to?
Yeah, so I actually know this was a great project. And in terms of guidance to complete publishing, I think, Maureen, you might want to bring up the showcasing specialist area here. But it depends also on the timeline, because some of our students were taking all 10 sessions to just finish the project. And other times that we finish the project within 3, and then we have 7 left to go to work on publishing. So it varies a lot, student to student.
Yeah. So we do have an additional 3 sessions called our premium showcasing that students can add on 3 sessions to their 10-session project to focus solely on showcasing. You have finished a project. Now what? How do we get it out? How do we get it out there? But also, if you look on our website, and Julie, if you email me, I can also send you the links directly. But if you look on our website, we actually have pages on showcasing, and if you go all the way down the page, there's a database of many different contests or publications that you can go and you can apply to. You can also have his project on our we just had a symposium on Saturday where our students got to present their projects. That's a way to showcase. And then we also have our another thing called RARs, where we archive all of these projects as well. But Julie, please feel free to email me directly, and I can talk to you about this. Somebody said, I mean, if Ross can mentor students to attend UPenn High School trading competition.
I don't know much about that competition in particular. Maybe that's something you could email Maureen about, and then she could try to direct information towards me or the other mentors who might be well suited for that.
Yeah. Okay. Do you have any recommendations on how to collect data? Text, for instance, text and human language.
Yeah, it really varies project to project. For example, I know with Julie, who typed in the chat, her son did a really, really cool project, but it was really hard to get data because it was very sensitive type of data that's rare to kind of collect from at home. So it depends. If it's text data of like you sending text messages to your family, that's easy to collect. If you want to collect Twitter private messages of celebrities, which another student really wanted to do, that we can't get that data, right? So it depends. My recommendation is to try to form your project in a minimal viable product way where you can show a proof of concept on data you can collect from at home, and then write your research paper based on that. If the idea is solid, it can be later applied to more expensive data, but just do your proof of concept with what you have.
Okay. If students can't finish their project in 10 weeks, can they add additional sessions to allow them to work with their mentors to finish those papers? Yes. The answer to that is yes. Okay, we're right at 9. Actually, it's 9:31. We're after 9:30. So first of all, everyone, thank you very much for coming. I actually am thrilled with how many questions everybody asked. I love it when the students are engaged, and obviously you kids are very, very interested in AI. I want to thank Ross because, as always, like, he is just a phenomenal mentor. His love of the subject just carries over and gets the students all excited. So again, my email is Maureen@polygence.org. You can always email me any follow-up questions, and there will be a recording of this webinar emailed out to all of the registrants in the next few days. Okay, so everyone, thank you very much for coming tonight. I really appreciate it.
Thanks, everyone.
Bye.